In Chapter 8, Part 8, we are simplifying square roots. So finding the exact answer is important in real-world problems. So we often want to find simplified radical form instead of using the decimal. So this means that there are no more fractions, decimals, or remainders inside that radical sign. And in this chart here, you will see a review of perfect squares. So when we say perfect squares, that means a number times itself will give you, a number. So 2 times 2 is 4. So the square root of 4 is 2. Square root of 16 is 4, because 4 times 4 is 16. So we will need these, or need to remember them when we go to do our radicals. So we're going to take a look at 93. Now, you will be able to plug this in the new yellow calculators that we got, and you will get a radical. But it is important also to know how to do it without a calculator. And the easiest way that I've found is by doing a factor tree. So we have 20, and we want to break that down to its prime factorization. So you could do a couple of things. We could do 4 and 5. We could do 2 and 10. It does not matter. So we're going to break this down to the prime factors. So we have 2 times 2 times 5. So because this is a square root, that means 2, we are looking to see what appears twice. So I'm going to circle my pairs. So I have a 2 that appears twice, and I have a 5 that is left over. So we would write square root of 20 as 2 square root of 5. So what happens is the pair, whatever number that is the pair, that number goes out front. So not 4, just the 2. And then whatever is left over is going to stay inside the radical sign. So 2 square root of 5. Taking a look at number 94, we're going to factor this out to the prime factorization. So we have 3 times 3 times 5. So I have a pair of 3's and I have a 5 left over. So we will have 3 times the square root of 5. 200, the square root of 200, so we're going to break that down. And again, you can do any combination. You will get the same prime factorization no matter how you go about it. So we're going to have a 2 times 2 times 2 times 5 times 5. And I'm going to circle my pairs. And this time I have 2 pairs and I have a single number left over. So we are going to take a 2 from the pair of 2's and a 5 from the pair of 5's, because it represents one pair, and we're going to multiply them together. So that becomes 10 square root of 2. In problem 96, we have the square root of 48. I'm going to do 6 and 8 and break this down to my prime factorization. So I have a 2 times 2 times 2 times 2 times 3. So again, we're looking for pairs. So we have a 2 and a 2, so that becomes 4 with a square root of 3 that's left inside. Okay, so now we're going to look at operations with square roots, starting with multiplying. And what you're going to do is you're going to take the numbers that are in front of the square root, and you're going to multiply them together. So 4 times 3 is 12. And you're going to take the radicals themselves and multiply them together. So 20 times 5 is 100. And now we're going to try to simplify if possible. And this is where knowing your perfect squares comes in handy, because the square root of 100 is a perfect square. It's going to be equal to 10. So this is the same thing as saying 12 times 10, which is 120. If you don't remember your perfect squares, you could break 100 down into its prime factorization. So that's 2 times 2 times 5 times 5. And because you have a pair of 2's and a pair of 5's and nothing left over, that is going to give you your 10. So if you know your perfect squares, that can save you some time. We take a look at part B. The same idea. We're going to multiply the 5 and the 7 together, so 35. And then we're going to take our radicals, square root of 2 times square root of 6, and multiply them to get the square root of 12. So 12 is not a perfect square, but we can break this down into its prime factorization. So 2 times 2 times 3. We have a pair of 2's and a 3 left over. So the 3 is going to stay inside the radical, and the 2 is going to go outside, but because there's already a 35 there, we're going to multiply the 35 times the 2. So this will become 70 times the square root of 3. The next problem we're going to look at is 103, and this is pulled from one of the Study Island questions. This is a practice keystone question, and it can be kind of confusing because you have an x in there. So the expression is shown below, 2 times the square root of 51x. So we want to find which value of x makes this equal to 10 times the square root of 51. So what we want to do is we want to think about, okay, how are we going from a 2 out in front to a 10? So what would we have to multiply? So what times 2 is going to give us 10? And hopefully you're thinking to yourself, well, that's going to be 5, which is correct. But remember, when we break down whatever's inside our square root, whatever number that is, when we break it down, we're looking to see what has a pair. So we need to have a pair of 5s for that to go out in front of the radical. So we're not going to say that it's 5, but we're going to say it's 25. So we're going to find out what number we're multiplying with 2 to get 10, and then we're going to multiply that by itself. So that's how we get 25. The last problem we're going to look at is 105, and this is the same kind of deal as 103. This is from Study Island. This is a classic keystone practice question. But it is different than the previous problem. We want to find, so the expression above should be further simplified for which value of x. So the easiest way that I've come about this problem is by telling people to factor out your 111. And I know it might seem weird and you're not sure where to start. Always start with 2. So take the number in your calculator, divide it by 2. If it does not give you a whole number, then move on to 3, and then keep going until you find something if you're not sure where to start. So 111 can be divided by 3, and it will give us 37. Now 3 and 37 are both prime numbers, so that's as far as we can go. And we do our factor tree. So the idea is we want to look at these choices, and sorry, some of them got cut off, and see which ones also have a prime factorization of either 3 or 37. So if they share a 3 or 37 when we factor them out, then that is the one that we want to choose. So if we take a look at 38, 38 can be divided by 2, so that's 2 and 19, which is not 3 or 37. 7 is a prime number, and that's not 3 or 37. 21 we can break down to 3 and 7. So that has a prime factor of 3. And then if we just want to double check, 106 is going to be 2 and 53, which is not going to work. So it's going to be C, 21. So you're looking to see, of the number that you have when you factor it out, what prime number does it share with one of your answer choices?